Now, we have to think about what percent, if we want 99%, the middle 99%, what percent is split between the two ends? 1. So what percent's up here? 0.5%. 0.5%. Half a percent. So what percent's down here? 0.995. 99.5%'s below. So you're going to have to do inverse norm 0.995. Again, once you calculate these, all you have to do is memorize them. Because if you want 99% in the middle, you have 1% to split up. That's a half a percent up here. So then below 99.5%. So inverse norm is 2.58. So in other words, if a 99% confidence interval, you're allowed to go like 2.6 standard deviations away. So these are the values that you need to memorize depending on the these are the most common ones. But let's say you wanted to do like an 80% confidence interval. Let's just say you want to do an 80% confidence interval. Then you'd say, well, the 80% in the middle, that's 10 on each end. So then, yeah, you'd do inverse norm 0.90. And that would give you how many standard deviations away you could go. So you can find the z-score, how many standard deviations away for anything. So what would that be? 1.28. Okay. So now you're probably not going to be asked an 80% confidence interval, but in case you are, you can figure it out. All right, so now let's go. There's another example now. This is exactly the same problem we just did. Now at the top, it's just, okay, again, a reminder, what's the general form of a confidence interval? So the confidence interval is the point estimate plus and minus the margin of error. Okay, again, this is the formula that you'll be given on the AP Stat exam. You might be given this one, the statistic plus and minus the critical value, that's the Z, or the T, it's the Z-score right now. That's the number of standard deviations. A Z-score, the definition of the Z-score is how many standard deviations away from the mean. So how many standard deviations away you can go, and then the standard error of the statistic, which is like the standard deviation using the samples. So the only formula we know right now is p hat plus and minus your whatever your confidence, your standard deviations for your Z is, times the square root of p hat times q hat over n. And the Z-score changes depending upon the standard deviation. So you'll just have to keep doing the problems enough and looking back so that you can memorize that 95% is 1.96, 90% is 1.64, 99% is 2.58. Now you can figure them out though if you didn't remember them. So now we've got one more example here. Recalculate the confidence interval for the true proportion with at least one piercing using a 90% and a 99%. Now, to save time, we're not going to do all the steps. We've actually already done the steps. We've checked the conditions, haven't we? Okay, and we've already said we're trying to estimate the true proportion of East High students with at least one piercing. So we're going to just conduct this. We're just going to do step 3 here and just step 3 for both of them. So step 3 for a 90% and then step 3 for a 99% confidence interval. Now when you name the type of confidence interval, this would be called a 90% Z interval for P, a 99% Z interval for P. All right, so to calculate it, we're going to take our point estimate plus and minus, what would be our, Z times the square root of P hat, Q hat over N. So that'll be the same formula we use for both of them. So what was our point estimate? 0.62. 0.62 plus and minus, that was the P hat is our point estimate. A point estimate is a sample value. Just a new notation here. So for 90%, what will I put for my Z-score? 1.64 times the square root of 0.62 times 0.38 over 50. The only thing that's changing from this formula to the one we did on the last page is the Z. It's the only thing that's different. But it will change the percent that we can add and subtract. 0.11?
Yep.
Okay. So what would you would take 0.62 and do what? Plus or minus 0.11, so 0.62 plus 0.11, 0.62 minus 0.11, so that would be 51.51 to 0.73. So this time we're allowing from 51 to 73%. Okay, now 99% confidence interval. 0.62 plus and minus, what is the z-score, or the standard number of standard? 2.58 times the square root of 0.62 times 0.38 divided by 50. Again, the only thing that changes is that critical value, the number of standard deviations you can go. And what do you get now? What percent are you allowed to add and subtract now? 0.18? 0.18. So 0.62 plus 0.18 and 0.62 minus 0.18. When you name a confidence interval, what number should go first always? The smaller number, small to big. It's an interval of values. So this would be 0.44 to 0.80. Okay, so now the other one we got, what was the answer from the other one? 0.49 to 0.75? Okay, so I'm just going to write all of these. So this is a 90% confidence interval, which was 0.51 to 0.73. This is a 95% confidence interval, which is 0.49 to 0.75. And a 99% confidence interval is 0.44 to 0.80. And I want you to look at these and compare them. What do you notice about the lengths of the intervals? They get wider. They get wider the more confident you get. Remember when I said it'll be between 0 and 150 degrees? And you can be what percent confident usually? 100% confident usually? Okay. The wider the interval, the more confident you can be because you're capturing more values. So 99% is going to be the widest one. Think about it. We were allowed to go 2.58 standard deviations away. Whereas in a 90%, we were only allowed to go 1.6 standard deviations away. So the more confident you are, the wider your interval is because you're capturing more of the stuff. So which factors affect the margin of error, the length of the interval? The confidence level, that would be the 90%, the 95%. You need to know that confidence level is referring to your percent. If we want to be really confident, you can increase the confidence level. It gives us a better chance to capture the true value, but it has less precision. Less precision. Sometimes you seem wishy-washy if you give too big of an interval. And the sample size. If you want more precision, you can increase the sample size, but it usually costs additional time and money. So two things that you can do to affect the length of the interval. That's the margin of error. So we only skipped one example, which is exactly like the example. It was just a repetition of the example we did. So there'll be a video. There's videos. There'll be 3 parts for videos. So.